There's this whole misconception with laboratory diamonds or any lab gemstones that they are fake gemstones, and I've often seen them referred to as fake diamonds. These have the exact physical, chemical, and optical properties as mined diamonds. These are in every way, shape, or form authentic diamonds. Hey, Rebecca.
Hey, Preston.
So I recently went on a trip, and I think the best way to talk about it would just be with a box.
I love it. That's how we do things on this channel.
Let's go. All right, so we got a clue here.
Okay. We are born from the best heat and pressure the crust has to offer. What are we? I just thought pizza. I was a little hungry.
Don't make me hungry.
Oh, okay. So this is a little clue to me. Oh, gorgeous. Okay, so the more familiar things for you guys maybe would be these two colorless faceted stones. This bag says HPHT, which means high pressure, high temperature, which is something that you associate with how lab-grown diamonds are made.
Absolutely. These are lab-grown diamonds, and not only are these lab-grown diamonds that we sell, but these are actually from the place that I went to.
Okay.
So we went to a diamond lab and we had an awesome time, and the people there were nice enough to let us bring some goodies back, and that's what these things are.
I love it. Okay, these are gorgeous.
These are, yeah, absolutely. Nice cuts, huge diamonds too, which is one of the benefits of lab diamonds. You can get larger sizes for a relatively lower price.
Okay, you said you went on a trip.
Yes.
Obviously, lab diamonds are made in a lab. So did you go to the lab?
We went to the lab. We went to 4 buildings there that they have where they do different steps of the process to create these lab diamonds. I think the best way to start here would be with this metal plate here.
Okay.
I had a general consensus as to how lab diamonds were made, but there are a lot more steps. So to put it in layman's terms, for a HPHT diamond to be made, the seed has to be placed in a cube. The cube is made of polypropylate, and then they place a diamond seed onto ceramics and surround it with graphite. This is on the exterior. So there are 2 of these. They are on the top and the bottom, and this was originally much bigger because this was subjected to a lot of pressure.
Yeah.
They get this cube, they place it into one of these machines, which is like a hydraulic press, in 6 directions, and it just presses in over the course of 7 days.
Okay.
Shrinks everything, and that allows for diamond to form in there. You know, heat is being generated from the pressure, and it kind of takes the graphite and grows it onto the seed, which is so small. Like, I'm talking a grain of sand.
Wow, that's the seed.
That's the seed. It's a grain of sand, and they put a disc of graphite on it, and when they pull it out, they have a kind of a cylinder. It looks like a whole cylinder of graphite, but they go through an etching process, putting it into like various acids, and it comes out with kind of an octahedral diamond.
Okay.
But that's just from the pressing. And these are slices of that HPHT diamond. And you can kind of see the structure of like a kind of an octahedral, like you see the lines going in, kind of like, almost like we're looking through like an optic axis on the top of an octahedral. And this is what they grow CVD diamonds on.
Got it. Okay. Do they also grow CVD at this lab?
Yes.
Okay.
So the HPHT process is a jump start for the entire thing.
Got
the
it.
HPHT slices are what they start with. They have 4 machines there that are pressing for 7 days, and they have about the 50% success rate.
Okay, that's actually not bad.
I asked them, it's like, what happens to the diamonds that fail? In my mind, I thought, okay, maybe we have like a salt and pepper diamond. Maybe we just have some of the carbon that just didn't crystallize, and we have a lot of inclusions in there. And they said, no, it's pretty much when we open it for a failed diamond, it's just like black sand. It doesn't even start the crystallization process.
Oh, that's wild. So they can't even use it for like industrial purposes.
They just gotta throw it away. They had all these bins full of just failed material, and we were like, what do you do with that? They were like, if you find out, let us know, because we have a lot of it. But you can see these rings right here. This is from the pressure. These weren't here before. And right here is kind of where those cylinders of graphite were.
I love that.
So
that is so cool.
Pressing in from all directions, and then 7 days later, you have a diamond much quicker than nature would have made it.
Yes. As you may or may not know, diamonds, when formed naturally in the earth, are formed in the upper part of the mantle, and they undergo intense heat and pressure. So again, you talked about graphite. Graphite is pure carbon. So you have to have carbon undergoing this heat and pressure, and in some amount of time that we don't know, makes diamonds in the earth. And so in a lab, you have the exact same conditions, and you have chemically, optically, physically the same product. It's just a different location.
And these are diamonds that are made from this process, from this exact place that we went to. So these are about 3-carat diamonds, which, like I said earlier, creating diamonds in a lab allows us to grow pretty big diamonds.
So these are for sale, so we can put the links in the description, but it's worth noting that these are very, very nice diamonds.
These are very nice
Both of these are F color, so when you're looking at the color grading scale, DEF, so F is still considered colorless. And mine is VS1, yours is a VS2, so very slightly included. So it'll take some time to see inclusions when looking at it under 10x magnification. And again, they're gorgeous.
Yeah, absolutely.
They're so beautiful.
And I think it's important to say that there's this whole misconception with laboratory diamonds or any lab gemstones that they are fake gemstones, and I've often seen them referred to as fake diamonds. These have the exact physical, chemical, and optical properties as mined diamonds. These are in every way, shape, or form authentic diamonds.
And a lot of people, I think that lab-grown stones, diamonds in particular, are perfect as well. So like they don't have any inclusions. You still color grade and clarity grade them. So again, you have a VS1, VS2.
There's a slight difference.
You have different colors. You definitely have inclusions. Now they are different inclusions. You're not going to find certain inclusions in a lab diamond that you would find in mined and vice versa. But you still have a gradation of quality of diamond. And again, these are beautiful. So definitely check those out. I should open it?
Go for it.
Okay. Okay. Ooh.
We've got a couple bags here. We've got some labels on them. Good, reject. I'm just going to pour these out.
Okay, I love it.
So it's pretty important that we have just an example of another diamond here for this process, because this is what it comes from. This is a diamond grown through the CVD, the chemical vapor deposition process. That is what it looks like. So these diamonds ran in the CVD machine for about 217 hours, which is about half the time they need to.
Okay.
So normally these would be double the size and thickness before they are pulled out of the machine.
And still black?
And still black, yes. You see this top is very bubbly.
Yes.
But if you flip it around, what do you notice?
It has a very flat and like a metallic luster.
Very flat
type
metallic.
of surface.
That's what that is.
Oh, that's the seed.
That's the seed. That's the plate that it's grown on. Not only are these diamonds created on top of HPHT plates, but once these diamonds are created, they actually get sliced into plates of their own so that they can keep doing it without relying completely on the HPHT process.
Got it. Well, that's inventive.
So right here we've got what they graded as good plates. You see they got nice clarity.
Right.
And right here are some bad plates.
Bad.
You know,
rejects.
Rejects. So if a diamond were to be placed on top of that, the impurities would continue to grow up through the entire diamond, which is not good.
That makes sense.
What happens in the CVD machine, basically it's a chamber with 4 little eye holes, and they place these seeds onto a giant plate. They place about 1,200 of these onto a plate. It seems very tedious. It takes about an hour and a half.
Oh my gosh.
In a very sterile environment. They do a really thorough cleaning on these machines. They flood this chamber with hydrogen, methane, and oxygen. Hydrogen creates a ball of plasma, and this ball of plasma kind of hovers over the plate. This ball of plasma separates methane into its components. So it separates the hydrogen from the methane and the carbon. So the carbon, of course, you need to grow diamonds.
Yeah.
The oxygen is doing a cleaning process. So this is all simultaneously happening. So the oxygen will go down and clean the surface of the diamond, and then carbon will immediately come and attach. And then it'll come clean, come attach, so on and so forth.
That.
So over time, it just grows higher and higher and higher. and you come out with one of these.
These are black.
These are black.
Obviously, that's colorless.
Yes, and this black, it's sanded off pretty easily.
Okay.
And sandpaper will not abrade a diamond, but it will take this coating off. You'll hold it up to a light, and you'll see through it.
Got it.
So it's more of a treatment process.
Got it.
You send off pretty much this, and then it gets treated to become colorless. And then they also cut and add color as well. So, but these are rejects. Normally, you wouldn't want all this bubbly stuff on top. You want a nice smooth surface. Almost looks like obsidian pretty much.
Okay, so but all of the CVD diamonds are gonna come out with that coating?
They're gonna come out looking like that.
Cool.
Yeah. So diamond is singly refractive.
Meaning that when light enters, it only bends in one direction. Whereas in doubly refractive, light enters and bends in two directions.
What I want you to do is to take some of these diamond plates. We've got the HPHTs and then the ones on the outside are the CVD growth. And I want you to rotate them in the polariscope and tell me what you see.
So that looks dark in 360.
For the most part.
Yeah, which makes sense.
Oh wow, yeah, that's a fun one.
So you have what's called strain.
So this kind of makes sense when we're identifying gemstones on the polariscope and we get a gemstone made of glass. We also see a lot of strain. It's just been rapidly heated and rapidly cooled, way too fast for the crystalline structure to be happy. So that's kind of the same deal with this. Some diamonds take 1 billion years to be created. This is made in 7 to 17 days. So to me, it kind of makes sense as to why these plates are heavily strained. If it has too much strain, it's not really good for growth, so they get put as rejects.
That is cool.
There's some pretty cool stuff in the next box that's related to this, so I think we should get that out too.
Okay. Oh, cool.
Okay. So, other than the beautiful faceted diamond, we have some waste material.
Okay. Okay, so we have round, brilliant, colorless diamond there.
Uh-huh.
So diamond has carbon at the base of its crystalline structure, so it is a crystalline material.
This is polycrystalline diamond.
Huh.
In essence, this is all that bad stuff, the bubbly stuff that you see on top of this.
Okay.
It's polycrystalline carbon. They don't want it. It's still diamond, but it's not grown on the crystalline structure.
How do you get that?
So when they get these diamonds, you'll notice that these are almost perfectly rectangular. They do not come out this way. They actually get put in a laser cutter.
Okay.
So what'll happen, they'll take these out. It'll go through 2 cutting processes. One like this, and the laser will cut out a square or a rectangle. It'll take all this off. The second process is, if they're going to make CVD plates, they'll turn it sideways, cut it into slices. This takes about 45 minutes to cut with a laser, and it's really cool to watch. This stuff is just what they could pick off or what comes off of the sides because it's not usable material. And they have so much of this that they're trying to figure out what to do with. If they find out, then they got a good market because they have bins and bins and bins full of that. There's a phenomenon that can happen in the machine that is not good for diamond growth, and what it was referred to is glow balls.
Okay.
And these are glow balls.
Oh, they're like little spiky.
They're a little spiky. Here's one with it on the plate itself.
Oh, that's cool. Looks
now,
like coral or
it
something.
does. Now imagine you look in a peephole, you'll see like a couple of things. One, you could see just a bunch of plates of diamond, just like a clear surface, beautiful. The other thing you could see is those plated diamonds with these burning hot embers on top of them. These glow balls, red hot, right on top.
Cool.
If you imagine this just sitting, you can see right there, just sitting on top like that.
Yeah, that's how these are, like these are attached here.
So this is diamond-like carbon growing faster than diamond, and this is bad. If these grow on top of these plates, then it kind of sucks up all the carbon around it. It suffocates the diamonds around it. It doesn't allow for the growth. So if you see too many of these, you're more likely to have a bad batch. They look really cool.
They are very cool, and I imagine if they're glowing, if you look in the chamber and they're glowing, that's really cool.
You know, you can see from anywhere a couple of these on a batch to dozens of these on a batch. If you see dozens of them on a batch, it looks really cool, but it's not
good.
It's not good.
It's not cool to the people at the
No,
lab.
it's not at all. So this is polycrystalline diamond, and it actually has a lot of industrial uses. We have diamond drill bits. Diamonds are amazing for abrasives because they're the hardest substance on the earth. So they can pretty much scratch anything.
So again, carbon can have a lot of different forms. So when you use a graphite pencil, for example, graphite is carbon. It's just crystallized in a different structure. That makes it weaker. And carbon in diamond is crystallized in such a way that makes it that strongest substance on the earth.
And right here I have some more diamond-like carbon. So
oh my gosh.
This is the material that was laying on the plate itself, growing around these diamond bits. So you can kind of see some square like etching in there. This is kind of just like a layer of snow, but it's diamond-like carbon. You turn it around, you can kind of see, I think it looks like polycrystalline diamond, kind of these bulges growing around it. This is what sits on the plate.
All of this is a good demonstration of how much goes into making one of these. And there is a lot of excess material that we have to figure out what to do with to maximize material usage when making these.
So after about 16.5 days of growth, they pull out the plate. You know, they get rid of all this excess material. They pull all of these, which would normally be double the size. They put it in a laser. They get all the poly diamond off of it, and the glow balls, of course, have nowhere to go, even though they look amazing. So what they do is they take the good material and they send it off to get it treated, to get it cleaned up. They'll make colorless diamond material, but they'll also make some other things, and that's in the next box.
Okay. All right. So after harvest, ooh, so we've got some colored diamonds.
We sure do. So this is the beauty of this whole process, is we can make colored diamonds as well as colorless diamonds. As long as we know the chemistry and the coloring elements and what's needed to create a colored diamond, we can do it. And we've got a whole sorts of colors here. We've got pinks, we've got some yellows and blues. I know they can make brown diamonds. Pretty much any color you can think of, they can make it. So what happens when these diamonds are harvested is they're sent off to their treatment facility, and they are treated and then cut into these beautiful shapes and colors. And I just think these are awesome. These are all also for sale.
So we'll put the links in the description there so you can check those out because they really are so unique looking.
All right.
I love this green.
These are really big diamonds.
They're very large.
These are very large diamonds. We got to go into their vault and see all of the diamonds that they had on site. And it always amazes me to look at these colored diamonds and you can see all the dispersion in them. The fact that it's a reddish diamond or a blue does not take the color out of it. These are so dispersive. They have so much fire and they're absolutely gorgeous.
Nice marquee there.
Nice marquee. I always think these hearts are really
They're really
cool
cute.
looking. Normally, I've seen the heart cut is kind of like a take on the pear, but you just cut a notch. This looks like it's been specifically designed to be a heart. It's really wide.
A lot of dispersion in that one.
But yeah, that was my trip.
I love those. We talk a lot about where gems are from and how we get them into our hands as loose gems or in jewelry. And for lab-grown stones, there's a lot that goes into them, and it's a huge process. Like you said, a lot of power going on in those buildings.
A lot.
So it's really cool to see the whole progression of how they're made and how they get to these beautiful colored and colorless stones.
Absolutely. And if you want to get yourself some of these diamonds, just check the links in the description. They're all for sale.
Yeah, definitely check them out because they all have really unique colors and cuts, and again, the story behind them is really interesting. So let us know if you get any of these or what you think.
Yeah.
We love lab-grown diamonds here.
Absolutely. And we love them so much, I think it's time we pick a couple for a closer look.
Okay, I'm gonna pick a faceted. So I love this emerald cut.
That is a gorgeous cut.
And one of the glow balls.
Oh, I was gonna take that.
I mean, obviously you see the diamond in its really beautiful finished form as the faceted stone. The glow balls just have a fun story.
They're so fun.
I loved hearing about those.
I think I will pick, just because the color's just pulling my eyes, this pink pear cut diamond. And for my process pick, I'm gonna pick this reject CVD plate. I just really like, a lot of people don't think of what could go wrong, like that lab diamonds will always come out perfect when that is not the case. Sometimes we get a little bit of inclusions, and I love inclusions personally. So let's take a closer look.
Okay, Preston, thank you so much for telling us all about your trip to Detroit. That is so cool. I love to hear about how these are made from start to finish, and I hope y'all did too.
Absolutely, I had a fantastic time. It was a really cool trip, really educational for me, and I hope you learned a lot as well. And of course, if you want to get your hands on some of these diamonds that were made from this process, be sure to check the links in the description below. Don't forget to like, subscribe, and ring that bell so you don't miss out on any future videos. Thanks for watching.
Bye.